Hello students, welcome to Sreenath Academy. In this video, we are going to discuss about the Visualizing Solid Shapes, which is the 10th chapter from 8th class CBSE Maths. I am Karthik. We are creating videos on all chapters on all subjects from class 1 to class 12. So please do subscribe our channel. Also like our videos, share our videos. Don't forget to hit the bell icon so that you will get the immediate updates from us. Okay students, so without wasting time, we are going to start this session. And the chapter is Visualizing Solid Shapes. We'll see the overview, the introduction, and after completing the introduction, we're going to see the views of 3D shapes, and after completing it, we're going to discuss about the next topic, mapping space around us. So how to map the space around us. So these are different ways they have mapped. And faces, edges, and vertices. What is the difference between thing, and what are the polyhedrons and which are not the polyhedrons, and what are regular polyhedrons, what are prisms and pyramids. So that is the small chapter, friends. So this is the overview of the present chapter which we are going to discuss now. So visualizing solid shapes. So in the class 7th, we have discussed about the plane shapes and the solid shapes. We have also already named them as 2-dimensional and 3-dimensional. So 2-dimensionals are planar shapes and 3-dimensionals are maybe called as they are the 3-dimensional solid shapes. Solid shapes. If you see which is the 3-dimensional shape, but if you see it is a 2-dimensional paper. So planar means the 2-dimensional objects which we can draw on paper. So 3-dimensional means the real objects which are surrounding us. So they are having length, breadth, and height. But planar are having only length and breadth. So that is the difference between the 2D and the 3D, 2-dimensional and 3-dimensional. Suppose if you see here, you see the square, it is the 2-dimensional one and it is the square. Suppose if you see here, it is the cone, it is the where it is. So it is the cone, students, and it is the 3-dimensional thing, and is the cylinder which is also 3-dimensional. So if you see here, it is the triangle. So triangle, it is the triangle. It is the cube which is the 3-dimensional, which is the circle which is the 2-dimensional. Circle 2-dimensional. This is the cuboid, so which is the 3-dimensional. This is the sphere. This is a sphere like ball, which is also 3-dimensional, students. Okay. So if you look at those things, all the shapes, 3-dimensional shapes, are single. But in the practical situations, so we come across the situations where different shapes are mixed up. Suppose if you see it is if you see look at this picture. So here it is having the cone shaped tent and a cylindrical shape side walls. So it is the cylindrical shape and it is the mixture of cone and cylinder. If you look at this, it is the mixture of two cylinders. If you see, it is a cone and it is a hemisphere, which is half of the sphere. And here two rectangles are there, and here two hemispheres are there, and here there is a hemisphere and the cylinder. So around us there are so many objects which are having two or more 3-dimensional shapes, students. Okay, that is the case happening. And views of 3D shapes. So if you look at the 3-dimensional shapes, okay students, if you look at these 3-dimensional shapes from different angles, from different views, they look like different. They look like different. If you view from left side, it is looking somewhat. If you look from top, it is different. If you look from front, back, different. Suppose this is the house. If you look at this house from the front side, so it is the front view. It is having some different shape. And it is the side view. It is shape is different. And it is the top view. Its shape is different. So for 3-dimensional objects, if your view has changed, the shape also changes. Okay, and this is the glass, and it is the side view, and it is the top view. From the top view it looks like a circle, from the side view it looks like a cylinder. So when you view in different angles, you view in different angles, so you will get different viewing angles. Like that the shape will changes. Okay students, shape will changes. And brick is there. If you look the brick from front, it is just like a rectangle. And you lift the, if you see the brick from the side, it is also looking like a rectangle, but here length is different. And if you look from the top, it is looking like two rectangles. So the top view is different from side view and the front view. So this is my phone. If you look from this, it looks like different, and if you look from this side, it looks like side view is different. So this is happening students. Okay, and here also some, these are the cubes, unit cubes placed here students. Suppose if you are viewing it from side, from this side, it is the side view, just two blocks. If you view from front side, it is having three blocks, and if you view from top, it is also only two. Like that happens friends. So the viewing angle changes the shape. If you look from the front, it looks like just a two, but if you look from the side, it looks like three. But if you look from top, it looks like this shape. So the looking changes everything. So again this, if you look from the top, it looks like three, which is like this. If you look from front, it is like two consecutive. Look from side, two consecutive side by side. So that's happening here. The side you are viewing is making the change. Okay, so try to do these examples. So if you see, what is this view which is the top view, what is this view which is the side view? This is the top, sorry, this is the front view, and this is the side view, and this is the top view. Like that you have to name. Okay students, mapping space around us. Okay, so if you have seen, we have discussed previously in the primary classes about the maps in the geography, in the social science students. So in the maps there are particular rivers, particular states, particular mountains, so where they are located, how they are located, like this. So we have traced out the route of rivers, roads, railway lines, traders, and many other things like that. So how do we read maps? What we can conclude and what we can understand while reading the maps? What information does you get? Is it any different from a picture? So we'll answer these questions in this situation. If you see here, there is a house and there is a tree and there is a fencing. It is the real picture. It is the real picture, and it is the map. It is the map regarding that house. Is the map regarding that house. So the tree is there, and entrance is there, and entrance is there. So to this house entrance is there, to this house entrance is there, and to this house entrance is there, this house entrance is there. And this is the empty space we are having in addition to the roof. So when we draw a picture and we try to kept as much as possible close to the real picture in the map. Okay, so if you see the location of the tree and the location of the tree in the map is exactly same, no, so we try to do like that. And different persons, and we'll try to get some relations between all these things. So if you different persons give different descriptions regarding the pictures and the positions, all these things students. But in the case of map, it is not true. The map of the house remains the same irrespective of the position of the observer. So wherever it you may be, but the position of house is same. So in others, words, perspective is very important for drawing a picture, but it is not relevant for a map. So for a map, perspective is not important. Okay, look at this map. So which was drawn by 7-year-old Raghav as a route map from his house to the school. So it is his house. So he walked along like this, he crossed and he goes like this, and it is her sister's house and it is his house. So how far is Raghav's school from his house? Can you know what is the distance between his house and its school? We don't know. So there is no particular measuring. Okay, and these circles know what that circle tells us. So whose school is nearer, sister's school or his school to home? So it is difficult to understand to get that information from this map. So it is not perfectly matched, the distance is not properly mentioned there. Okay students, now look at the another map drawn by her sister. Okay, so she is 10-year-old. Okay, so it is like that. So if you see that Meena has used different symbols. If you see here, it is this these are the symbols. It is the for pharmacy and it is for the petrol bunk, like this, and he has mentioned all the symbols here. It is the school, it is the shop, it is the house, like that. It is the house. So if this symbol is there, then it represents that we have to understand that there is a house. And she also mentions the distance here, 1 kilometer and 1/3 kilometer and 1/4 kilometer. So she mentioned the distance also. She mentioned the lake, pond, and she mentioned the everything like this, students. Okay, so there are the longer line segments and shorter line segments. So this is somewhat beautiful and it will really help you to get some more knowledge, students. Okay, that's what happening here. So now can you answer the following questions? How far is Raghav school from his residence? Raghav school is this, and it is 1/3 kilometer, 1 kilometer, and 1/2 kilometer. So if you add these things, you will really get that answer. Whose school is near to? Whose school is near? If you see, it is 1/4 and it is 1/3. So 1/4 is smaller now, so this school is very nearer, as these two distances are same for both. Which are the important landmarks? So what are the important landmarks are here? They are mentioned like that, students. So by using certain symbols, certain measurements proportional to the real life, the map is very easier, students. On the proper scale, it is also helpful. Okay, that's helpful, students. Okay, and sometimes while drawing the maps of the same size, so we'll take the scales. Okay, students, the distance proportional to the scales, students. That is 1 centimeter of space in the map is equals to 1 kilometer or the 10 kilometers in the real world, like that, students. The larger the place and the smaller the size of the map drawn, the greater is the distance represented by 1 centimeter, students. Okay, like that. So a map depicts the location of a particular object or a place in relation to the another object. Okay, so you can understand the relation between two objects distance. Symbols we use, that's it, friends. Face, edge and vertices. So this is the 3-dimensional object which we know here it is. So which is the face? If I will draw here and I will show. I have already shown you in the previous class. I again show. So what are the faces here? So it is the face, it is the top face, it is the top face, it is the bottom face, and this is the sides, 4 sides. These are the faces. What are those, friends? Faces. Next. So if you see here, these are the edges. These are the edges. What are these? Edges. These are the edges. So then if you see, look at, so it is what? It is the vertices. These are the vertices, the corners. The corners are called as the vertices, friends. The corners we call them as the vertices. So these are corners are the vertices, and the line segments joining the vertices is the edges. And if there are 4 edges, then it is a face. Okay students, like that. Each of these solids is made up of polygonal regions, students, which are called its faces. Okay, so these faces will meet at some edges, which are line segments, and the edges meet at vertices, which are points. Such solids are polyhedrons. So if you see, whenever there is a um, polygonal regions, here if you see there are polygonal regions are there in these things. Okay, so faces, here it is having 5 faces, 1 2 3 4 5, like that. And these faces will meet, will have edges and the points, so these are the polyhedrons. So if you see, these are the polyhedrons and these are not the polyhedrons. So all these are having faces. Okay, these are also having faces, but they are curved faces. Curved faces. Whenever the faces are curved or spherical like that, then these are non-polyhedrons. Whenever the faces are flat like these, polygons, flat plane surfaces, then these are polyhedrons, students. Okay, so how are polyhedrons different from non-polyhedrons is, so it is a curved surface. Cone, it is also lateral surface curved. It is also lateral surface curved. So these are the curved surfaces. So whenever there are curved surfaces, they are non-polyhedrons that are not made up of polygon faces. So convex polyhedrons. So convex polygons are similar to convex polyhedron. So these are the convex polyhedrons. These are having the flat surfaces. These are not convex polyhedrons. Okay. So coming to the definition of regular polyhedrons. So when will we say polyhedron is regular? If its faces are made up of regular polygons. So regular polyhedrons is if its faces are made with regular polygons, not curved surfaces. Regular polygons, rectangle, square, cube, like this, square, pentagon, like this shapes, which means, and the same number of faces meet at each vertex. So at each vertex, if it is a vertex, how many edges are meeting? 3. Here 3, here 3, here 3. So at every corner, at every vertex, same number of edges are meeting, then it is a regular polyhedron. So this polyhedron is regular. So here, here and every here, same edges are meeting, and it is not regular. Okay students, here 4 are meeting, here only 3 are meeting. Here in this vertex here, 3 edges are meeting, but in the edges B, 4 edges are meeting. So this is the problem. So it is not the polyhedron. And 2 important members of polyhedron family are, what are the important polyhedron families are? Prisms and pyramids. These are the prisms and these are the pyramids. So what is the prism and what is the pyramid? So both are the polyhedrons. So whenever there is a polyhedron whose base and top are congruent polygons, whose base and top, so if you see the base and the top, both are congruent polygons, and whose other faces, lateral faces, are parallelograms in shape. If you see, all these are parallelograms. So base and top must be congruent and lateral surfaces parallel. These are prisms. Then what are pyramids? So pyramids is, base is a polygon of any number of sides. Base, it is a polygon, and whose lateral faces are triangles. Lateral faces are triangles with a common vertex. Whenever the common vertex is there with the triangles, these are pyramids. So a prism or a pyramid is named after its base. Suppose if there is a square base, square prism, triangle base, triangle prism, square pyramid, square base, square pyramid, triangle base, triangle pyramid, like that, students. That's it, students. So finally our chapter is completed. Hope you have understood well, students. If you have any doubts regarding this, please feel free to comment below. Have a nice day, and we will see the summary of this session. We are also providing the tuitions. Make use of them. Go through the description, contact number is there, and don't forget to hit the bell icon so that you will get immediate updates. Visualizing solid shapes. So solid shapes are the 3 dimensionals and the planar shapes are the two-dimensional. So two-dimensional having length and breadth, three-dimensional having length, breadth, and height. So we have just revised the different three-dimensional, two-dimensional shapes. And so sometimes the real life objects are made up of combination of three-dimensional shapes, and from different viewing angles the three-dimensional shapes looks like different, and we have to observe carefully. Next thing is about the faces, edges. So mapping around us, we have discussed about how to map around us situations. And so corners are the vertices, and the line segments joining the vertices are the edges, and the edges are covered by face. Polyhedrons means they're having the faces, flat faces, and the edges points like that. So regular polyhedrons means they must have flat faces, not curved faces. And regular polyhedrons means they should be rectangle if they have a regular polygons as the base, and the same number of faces meet at the edge each vertex. Prism is having base and top congruent, and lateral surfaces are parallelograms. Pyramid is having base and the lateral surfaces are triangles. That's it, students. Chapter completed. Summary of this session is completed. All the best for future exams. Have a nice day. Bye bye.